Hello everyone, welcome back to another daily dynamics problem. Today we'll be going over question 7 in the MIT AP Physics 1 workbook. That will be in the description down below for you guys to follow along. With that being said, let's go ahead and read the problem. It says a uniform rope of weight 50 newtons hangs from a hook as shown above. A box of weight 100 newtons hangs from the rope. What is the tension in the rope? And our answer choices is 75 newtons through the rope, 100 newtons throughout the rope, 150 newtons throughout the rope, and it varies from 100 newtons at the bottom of the rope to 150 newtons at the top. So it's asking us what the tension in the rope is, and we have to look at what they gave us. So if we set our variables up, we can see that mass of the rope and the mass of not mass, but the weight force, so the weight of the rope, and then the weight of the block. Here they said that the uniform rope weight of 50 newtons hangs, so 50 newtons is our weight, and then the block is shown a weight of 100 newtons. So the weight of the block is 100 newtons. Here we can see that A is saying that somehow we decrease it, and no matter what, there's no way we can get below either 100 or 50. So I can see how we would have maybe 75, but there's a reason why there's no way we can get 75. Because it's asking us what is the tension in the rope. If the tension is up here, if we calculate the tension up here, this hook is supporting the weight of the block, but also the weight of the rope. So in total, that would be 150 newtons. Here, it would be around 100 newtons from the blocks already, and then some portion of the weight of the rope. So no matter what, it's going to have that 100 newtons from this block. So there's no way that it can be less than 100, letting A be crossed out. Now, going on to choice B, C, and D, C says that it's 150 newtons throughout the rope, but as I just said, it would be 150 newtons at the top. But let's say we have the weight force, if we calculate it at here, as I said earlier, we're only halfway. So if we was halfway, we wouldn't be supporting the whole 50 newtons of the rope, meaning that it wouldn't actually be 150, but it would be actually less than 150 newtons since it's not the whole rope, meaning that choice C is incorrect because it's not 150 newtons throughout the whole rope. And that leads us to choice B, which is incorrect because choice B is saying 100 newtons throughout the rope, but we already said that it's 150 at the top and it's not 150 lower down, meaning it does change. So leaving us with our only choice being left as choice D, because as I said earlier, at the top it says 150 newtons at the top. So at the top we're supporting the rope and the block, which is a total of 150 newtons. And then it says at the bottom of 100 newtons, which makes sense because here the rope is now only supporting the block, meaning it's only holding 100 newtons. The tension and the force is going to be only the 100 newtons at this point because the rope is not supporting itself at this moment. It's only supporting the block. But here on the hook, it's supporting both the rope, the tension in the rope, and the block, leading it to be a total of 150. And then as I just said, here the tension is here, so it's only supporting the block doing all the work, leading us to choice D as a correct answer. I hope you guys enjoyed the video. If there's anything you didn't understand or it was complicated, please comment down below and I'd love to go through and answer those questions. And remember guys, to enjoy life.